Hello, welcome to another episode of THP Tutorials. In today's video, we'll be taking a look at operations management. We'll be continuing with our practicals on location planning and analysis. Very well. In this video, we'll be looking at the CVP analysis or the cost volume analysis, right? CVP stands for cost volume profit analysis. Very well. So the assumptions of this method of evaluating locations are: one, fixed costs are constant, right? Variable costs are linear, that's they are constant per unit, and output can be closely estimated. And then only one product is involved, right? So the location that you're picking, you're only going to deal in one product. That's one of the assumptions that this model will make. And also the output can be closely estimated, right? You are choosing locations, so you are estimating the output that you would like to be producing per period at these various locations. And the goal is simply to find the location that will give you the lowest cost, right? In correspondence to the output that you intend to produce. So these are the assumptions. Very well, right? Now in the course of this video, we'll also look at a concept known as the cost over point, right? So let's look at the steps, right? So cost profit volume analysis. There are three steps involved. The first step is to determine both fixed cost and variable cost. We add them to get the total cost, and the total cost is what do you use the total cost for? We used to plot our graph to get the total cost lines or curves. Then we determine the lowest total cost, and that's how we make our evaluation. Well, so we'll look at a question, right? So total cost is equal to what? Total fixed cost, that's the TFC, plus the total variable cost, TVC, right? But total variable cost has its own formula, right? So, but total variable cost is equal to variable cost per unit times quantity. Remember that in the assumption that we made, we said that variable cost is what? Is linear or is constant per unit. So you see that this is constant per unit, it does not change. So to get the variable cost, we multiply the variable cost per unit by the quantity Q. Right, so that gives us an ultimate equation of total cost being equal to total fixed cost plus variable cost times quantity. Right, so this is the simplified formula for total cost. So here we have a practical question, right? Location A, B, C, and D. These are the fixed costs and they don't change. Now in this question, we'll be only giving the variable cost per unit. For the location A was 11, for B was 30, and for C was 20, and then D was 35. Expected volume Q, 10,000 units. That is to say that at these various locations, we are planning on producing 10,000 units of a single product. Remember, single product. Very well. Now we'll touch on the crossover points very soon, but let's deal with this aspect first. So the first thing that we need to do is what? We determine our fixed cost and then our variable cost. Our fixed costs are already here. So we are making a variable cost per unit. Then we have what? The expected quantity. So how do we ascertain or how do we arrive at our total variable cost, right? You need to do what? The VC times the Q. So the variable cost per unit of each location times the expected volume, right? So for location A, it would be 11 times what? 10,000, right? So if you look on the screen, 11 times 10,000 was not on the screen, right? It was there. So 11 times 10,000. That will give us what? 110,000. 30 times 10,000 become 300,000. 20 times this is 400,000. And 35 times this is 350,000. Alright. So now we have to get a total cost. The total cost will be this fixed cost, this total fixed cost plus the total variable cost. So this plus this, right? So as you can see on the screen, so you see that that's how they got the 360,000, because 250 plus 1110,000 will give us 360,000. This plus this is 400, right? Let's check on the screen. See, 150 plus 400 down to the 50. And D is what? 550. We are going to do our first step, right? To draw the graph. So just look on the use the one on the screen. Right. So you see that the different colors are denoting each location, right? Location A is the yellow, location C is the red, B is the gray, and D is the blue. But before I touch further on it, do you remember what the equation of a straight line is? Right. So the question is, how do we draw this curve? Like how do you get a point? Because I have seen that you have only plotted cost over time by quantity, right? Alright, what is it? This? The cost. What is the cost? The cost, then what? The output. So how did they get this? You have to draw your mind back to the equation of a straight line, which is what? Y is equal to mx plus c. Right? The light is affecting it, right? So y is equal to mx plus c. So remember from back in the day what? M is the gradient, right? M is the gradient, is the x coordinate, and then c is the y intercept. Now let's take a look at the total cost function. Is what? TC is equal to is DFC, right? But for the sake of this, I'll bring the variable cost per unit, the total variable cost first. So that will be VC times Q plus what? TFC. Right. So you see, so it's the same thing. So in the same way too, you see the gradient too is constant per each x variable, right? So so the variable cost over here is the gradient, and then Q is the x coordinate. That's why the output, which is the Q, was plotted on the x axis. I getting it? And then the total cost being measured in dollars, right? Measured in dollars. Being measured in dollars is what? Is the y. So that's why we put the dollar here and then the output over here. And then C is the y intercept. So the total fixed cost is also the y intercept. So that's how come we draw this line, right? So you know that the C is a y-intercept, and the y-intercept means that that's where the curve, the linear curve, these are all straight lines, they're called linear curves. That's the point where the linear curve will cross the y-axis. So to draw, let's say location A, the fixed cost was 250. You find 250 over here on the total cost line. So you stand on the fixed cost, and then you look for the total cost, which is 360, right? So maybe that will be somewhere here. No, that was too far. Maybe somewhere here. You can go right here. And just do it like this. To pass through it. So that's how come we got these lines, right? So you can check. This is the one on the screen is already made, right? So let's just use that one. So that's how come this case was done. So that A is the yellow, right? What was A's fixed cost? It was 250. So just check. So that this yellow line is right between 200 and 300. D is the blue, and its fixed cost was 200,000. So that 200,000, this blue line is right over here, right? And if you check this total cost of 250,000, and that's somewhere D being the blue, right? It's not being made accurately, but that's how you draw the line. So you stand on the fixed cost, then you stand on the so you do the fixed cost, which is the y-intercept or the total cost intercept. And you stand over here at the total cost and you draw the curve. Since that at the crossover point, the total cost of A is equal to the total cost of B. What this is trying to say is at this first point, right? This first point where you have what? Is it B and C intersecting? At that same point, it means that they have the same total cost. Are you getting it? So the total cost of B will be equal to the total cost of C. So let's make this B and C. So what do? You equate them. So you have what? Total cost of C is equal to the total cost of B. Now you get the total cost of C. You come over here and C, right? So you won't add this side. So this total cost will be 200 and let's do for C first. So finally for the total cost of C will be equal to this fixed cost of 150,000 plus what? 20Q. Because at this point we don't know the quantities the quantity that will give us the total the unequal total cost. Then you come to the total cost of B, which was 100,000 plus 30Q. Getting this, what do you do next? You equate them. So you have what? 150,000 plus 20Q is equal to 100,000 plus 30Q. And then you solve for Q. Let me do that quickly. See, when you do that, you have 5,000 units. So how do we interpret this? So at the crossover of 5,000, so you check the exact, so that this is 486. It's in thousands, right? So this is This is what 5,000 units, right? 5,000 units. So that's it. And what that means is that if you want to produce between under 5,000 units, then location B is your best choice. It's your best option, right? And it's that it is that line that is extending, right? So that it's B's line that's over here out to the crossover point. So it means that if you want to produce between B under 5,000 units, B is your best location. And whereas that in the next side, where it is C's graph that is at the bottom. See, right? So it sees one, it sees curve that's over there. So it means that now what we have to do first is come and find for this next crossover point. So that's what. Let me try and draw something. So we'll have further insight into this. Right, remember so that trying to find the lowest cost locations, right? So this is how you get the lowest cost. Look at the bottom of all the graphs drawn. So realize that from this point is B, that's the lowest line, B is the lowest curve, right? Then they go to this point of the 5,000 units. What happened at that point? At that point, C became the lowest curve. So this is the red is the lowest over here. All the other curves are above it. Right, so it means that between this range of 5,000 and 11,000, well, we have to solve for. So you see that this next curve. So C range from was the lowest cost between 5,000 units and 11,000 units, right? And then it crossed over. So that's the crossover point. So it crossed over to what? So beyond 11,000 units, A became the superior location when you want to produce above 11,000 units, right? But for the sake of clarity, let's calculate and get the exact cost for that location, the crossover point, the quantity that will give us. So that's between what C and A. We already have C's equation over here. So it will be total cost of C is total cost of A. So A, right? And A was 250,000. Then 11Q. So $250,000. That's 11Q. So 250 comes here. Minus 11Q. That gives us 20Q. 20Q minus 11Q. Giving us 9Q. Which will then give us 10,000. So yeah, 100,000 instead. So 9. Right. So let me use the calculator. So 100,000 divided by 9. Right, that'll give you 11,111.111, by its quantity. So just take 11,111 units. Right. Eleven thousand one hundred 11 units. The figure that you get. So now you can finally interpret it. Right. So that's how you get your crossover point. So you can still, this will be a better guide, right? You're taking the lowest cost. So you just, after you sketch your graph and everything, just look on your work and you have that from this point is B's um, graph or curve that's at the lowest, right? And then moving, when you go to this point, C crossover, that was above 5,000 units. It crossed over up to what, the 111. And what happened? From that point, A became the best choice or the lowest cost location, right? So how do we interpret this graph? We said that what, if we intend to produce below 5,000 units, B is our best location or our cheapest location. And if we are looking to produce above 5,000 units but below 11,111 units, then C is our best choice. And if you want to produce above 11,111 units, then A becomes our superior option, right? So that's how we do the cost volume profit analysis, right? So make sure you have this formula in mind. Not all questions would require you to draw a graph, right? I think when you are when it is demanded that you solve, so this is a question. It says when you are demanded to solve for crossover points, I think that's where the graph comes in. But you don't really need a graph, so it depends on the question. And maybe you check the marks being given all that, and you get to work, right? So look at this. Location A would result in annual fixed cost of 300,000, right? Let me talk about the pen. You see, what I thought about location A would result in annual fixed cost of 300,000, right? So you have location A, and they ask annual fixed cost of what? 300,000. It's no less. And location B, okay, and the variable cost, so the VC is what? Wow, this is VCO. The variable costs are 55 per unit. What is the variable cost per unit? 55. Then for location B, it was what? 600,000. And 32. The sales volume is estimated to be 30,000 units. So Q 3,000 units. Which location has the lower cost at this volume? Right? You have the quantity, you have this, and you have this. So I won't solve the question. This is the total fixed cost. You already have that. So you need to find for the total variable cost, which will be what? This is VC and the quantity. So you just get what? So multiply this by this, and this, then you add this to this to this. Then you get your total cost. Then all you simply have to do is that you compare them and you take the lowest one. So which location has the lowest at this volume? You say that maybe location A has the lowest at this volume, or location B has the lowest at this volume. And how large is its cost advantage? So the cost advantage will be the difference. So if location A has the lowest cost, let's subtract B from A or A from B. And the difference that you are getting, so you said that location A has this difference. So maybe if location B is 400,000, location A is 350,000. location B is the obviously going to be the cheaper location. So what's his cost advantage? It will be the 400,000 minus the 1050,000. That will give 50,000. So 50,000 will be the cost advantage of location B. Right now, how large is its? At what volume are the two facilities equal? Right. So I thought volume are the two facilities equal. That will become what? 300,000 plus 55 Q is equal to 600,000 plus 32 Q. You equate and solve for Q, then you get the quantity, right, and the volume or the quantity. So you realize that this is relatively quite very, very cheap, very, very simple, right? Very well. So thank you very much for watching. Please don't forget to like and subscribe, and you can just check out the factor rating video